This is Mr. Anderson from Keller Community College. I'm going to talk to you about some of the problems in section 2.5, some of the more popular problems, and we will be working with page 127, problem numbers 110, 113, and 114. So we're going to start off with problem 110, which is written kind of it's written very cleverly to make it sound like it's harder than it actually is, but it actually has it actually isn't so bad once you get around it. It says for a linear function g of 3 is equal to -5, and also g of 7 is equal to -1. Now, if you look at this here, this is just another way of saying that when you plug in the value 3 for x, you get -5 for y. So this is technically the point 3 comma -5, and this is point, when you plug 7 in for x, you get -1 for y. This is 7, -1. Then it asks you to find an equation for g. So knowing 2 points, we can use the calculator shortcut, or we can just go y minus y over, that's a 1 there, y minus y over x minus x. So this becomes -6 over, oh wait, y minus y. I forgot to make that plus. Sorry about that. Let me fix that. That's going to be -4 over -4. So we're going to make this problem here reducible to 1 over 1, which is just 1. So my slope is 1. Now, we're going to take one of these 2 points and plug it back into this equation, y equals mx plus b, to find our y-intercept. So I'll pick the first point here. So I'm going to take -5 for my y. My slope is going to be 1. My x is going to be 3 from the point that I chose, equals b, or plus b. Then I'm going to take this, 3 times 1 is 3, put the -5 over here, and then subtract 3 from both sides. So I get -8 equals b. So there's my answer here. Y is equal to x minus 8. Now the 1 is still there from the slope. That's still there. And the -8 is the y-intercept, which is still there. So there's part A of the problem, is to find an equation through those 2 points. And again, as I said, the problem was written pretty cleverly to try to confuse you a little bit. So now I have g of x, which is the same thing as y equals x minus 8. And part 2 asks, find g of -2. Well, what's nice about that is you just plug -2 in for the x and solve. G of -2 is equal to -10. Then it says for part C, because this is part B right here, then it says for part C, find a value of a such that g of a is equal to 75. What that means is, what value of a do I plug in for x to give me 75? Well, take your equation, which is y equals x minus 8, and make 75 the y value. A is going to be my x value. I'm plugging, a in for x minus 8, and then I'm going to add 8 to both sides, and that will give me an answer of 83. 83 is equal to A. So there we go. Looking pretty good there. All right, so now let's talk about problem 113 and 114. And problem 113 is going to require a graphing calculator. So let's clear this out here. Bring up our graphing calculator. Now, a couple things you'll want to do here. First of all, when you turn this on, you'll probably not see this screen. You'll probably see just a blank screen here, or a graph that you may have typed in before. So click the Stat button, which is underneath the delete key, and then click Enter. Now, you should have list 1 and 2 clear of data. Now, if you don't have this clear of data, like let's say you've got some numbers like 5 and 6, you can always go up to the top at L1 and hit clear and then enter, and that will get rid of those lists there. Because in problem 113, they're asking you to use the linear regression function. Taking a look at some incandescent wattage, so we're looking at some values for x and the CFL equivalents right here, which is the wattage of the fluorescent lights. So the incandescent wattage is 25, and you'll see I'm just actually typing this into the calculator just from the table that they've given you. And let's go to the lower wattage fluorescent lights here. So we have 5, 9, 15, 25, and 28. Okay, now that we have list 1, our X values are the wattage, and we're looking at the CFL equivalent, we can use the linear regression model to plot points. It will actually put the points into the calculator without you seeing it, and it will find the best slope and y-intercept. So you first click Stat, then Write, then For, and then Enter. If you have a new calculator, you may have a new screen on here, and it may say Calculate, so move your arrow down and click Calculate there. But either way, you should get this on your screen, which is the slope and the y-intercept. Now, if I went too fast, let me do it again. Imagine you had a clear screen and you just typed in these values here. So we're going to go Stat, Write, For, Enter. Now this will freeze my calculator and I can write on the screen here. It looks like my slope, my A value, is the slope of the problem. So this is our slope. Our slope's right there. And this is our y-intercept right there. Okay, so there's our slope on our y-intercept. So it's good to write down the equation y equals 0.2, and I'm going to round to the nearest hundredth here, no, thousandth, sorry, 256 x minus 1.746, or 256 thousandths minus 1 and 746 thousandths. So Part A asks you to find this equation, and Part B asks you to kind of approximate right there. It says use the function in Part A, so here it is, to estimate the CFL wattage equivalent to the 75 watt incandescent bulb. So what we have to do is we have to find our wattage for f of x for a for a 75 watt bulb. So I'm going to plug in 75 into this problem for the x. So my f of 75 is going to be equal to 0.256 times 75 minus 1.75. Now I'm not going to do this on the screen here because that would get rid of all the writing I've done. So off screen I'm multiplying these two together, giving you a little bit of time to do the same. And this gives me approximately 17.45, so roughly about 17 watts for the CFL equivalent. So notice these are kind of wavy equal signs because they're not exactly right on them. It's an approximation, of course. Okay, so let's go to the next problem here, and we're going to clear this out and go to my calculator, because problem 114 is the same kind of problem. They're looking for you to type things into your list 1 and list 2, and I actually already have these typed in, so I have them in another list. So this just saves you from watching me type all these in, from 1920 all the way up through 2000. You can scroll down to see where they are, and again, when you need to clear out the numbers, you can either overstrike or just hit clear, enter, and then that will get them erased. Whoops, I did that again. Hold on a second here. Just want to get my data back here so we can use it for problem 114. Okay, now that this is all typed in, you can go Stat, Write, For, Enter. Now again, with a newer calculator, you might have to scroll down to the word Calculate, but that is where you're going to get that data. Now let me freeze the screen and move over here. So what I have here is I have problem 114. Okay, and problem 114 is asking to find the equation of the function. Well, that's going to be y equals 0.299, or 299 thousandths, x minus 515 and 362 thousandths. Okay, so that's our equation for figuring out the year and life expectancy. So now the question is try to figure. Let's see if there's any other part of this here. Try to find your life expectancy in 2012. Okay, well, if we're trying to find our life expectancy in 2012, we're going to take our equation, because the x is the year, and we can type in 2012 in for this. So if you were born in 2012, and I think this is just life expectancy of women, so sorry guys, they're going to outlast us here. Alright, so again, I'm not going to type this in on the calculator like on the screen, since that would erase everything I've written so far, but I'm going to plug this in here. 2012 minus 513 and 362 thousandths. Looks like if you were born in 2012, your average lifespan is going to be, drumroll please, 88.226. So roughly about 88 years of age. That's your life expectancy for women. All right, so thank you for watching. If you have any questions, just let me know.